There's this very specific kind of modern farming frustration. It's not the weather, not really. It's when you're in the cab of this incredible machine, sun's coming out, coffee's hot, and you're ready to move a mountain of dirt.
And then you look at the screen.
You look at the screen,
Yeah.
the laptop, running AG Form 3D,
Oh.
and it just says, no.
The red light, float status.
Yeah, the red light. Or you get a little pop-up that just says, infeasible. And suddenly, you're not sculpting the earth, you're just, fighting with a computer while the day gets away from you.
It's that classic digital versus physical problem, isn't it? The software is supposed to be magic, but really it's just a calculator. And if the numbers don't add up, it just stops.
Exactly. And that's our mission for this deep dive. We're not talking theory.
Yeah.
We are troubleshooting the big three headaches that stall these landforming projects before they even start.
The ones that really burn up the clock.
For sure. So we're going to figure out why your GPS won't turn green, how to deal with that variable slope math, and how to set up the grid so your field doesn't end up flying across the county.
Which, it happens more than you'd think.
I bet. So for this, we've got the official AG Form 3D user manual, version 14, so it's current. But we're also pulling in some real-world advice from tutorials by OptiSurface and a YouTuber who goes by Mike Tyson.
Not the boxer, I'm guessing?
No, not the boxer.
Yeah.
But honestly, when you're staring at a glitchy map, the name kind of fits the mood you're in.
It does. His tutorials are great, though. He really knows how to knock these problems out.
Perfect. Okay, let's jump in. I'll start with the thing you can't see, the invisible foundation, the survey grid.
Right. And you have to stop thinking of it as just lines on a screen. It's the mathematical skeleton for the entire job. Get the skeleton wrong, and the whole body is wrong.
And the first choice you make is the grid interval, the size of the squares.
Yep. So let me ask you, if you want a perfect, super detailed map, what's your first instinct?
We make the squares tiny.
Yay!
Like a 10-foot grid, capture every little bump. More data is always better.
That's the logical trap, and it's the fastest way to choke your system.
You mean it just slows down?
It grinds to a halt. Think about the file size for 100 acres on a 10-foot grid. It's massive. Then you load that onto the machine control box in the tractor.
Man, its little brain can't handle it.
It can't. The screen lags, the blade control gets sluggish. You've basically given it too much reality to process in real time.
Okay, so 10 feet is too small. What if I go the other way? Let's say 50 feet. Make it super fast.
Then you're missing the important stuff. You could have a 20-foot wide swale, a little dip that falls right between your grid lines.
And the software never even sees it.
It just draws a straight line right over it. So you grade the field, you think it's perfect, and the first time it rains, you've got a pond that the map said wasn't there.
So there's a Goldilocks number here.
There is. The consensus from the manual and the experts is 25 feet, or about 7.5 meters.
Okay, 25 feet. That's the sweet spot.
It captures enough detail without overwhelming the processor in the cab.
Got it. Now, what about this flying field problem? This one is just bizarre. Yep. You import your survey data, and the field is like 3 miles down the road on your screen.
Or floating in a river.
Yeah.
How does that even happen? Aren't coordinates just coordinates?
You'd think so. This is almost always a projection error. A lot of surveyors use what are called state plane coordinates. They're super accurate for a very specific local zone.
It's like a local dialect.
Perfect analogy.
Yeah.
But AG Form 3D and GPS in general speaks a global language, latitude and longitude. When you import a state plane file without telling the software exactly which local dialect you're using,
Mistranslates.
horribly, it reads the numbers but puts them in the wrong place on the global map. The fix is just don't do it. Whenever you import, choose latitude, longitude if you can. It avoids the whole headache.
So stick to the universal language.
Exactly.
Okay, one last thing on the grid. Most fields aren't perfect squares aligned north-south, but the grid is.
Yeah, and that's just annoying to look at all day. If your crop rows are diagonal, the guidance lines on the screen look all jagged. It's just visual clutter.
So how do you fix it? Just guess the angle. No, don't guess. You use the measure tool. You find the longest straight edge of your field on the map, click one end, click the other, and it'll tell you the exact azimuth. Let's say it's 210 degrees.
Okay.
You just go to Field Options, Survey Grid, type in 210, and boom, the whole world rotates to match your field.
That sounds incredibly satisfying.
It is. Then you can use Shift Origin to move the center lines out of the way, just for housekeeping. Keep the map clean.
I like that. All right, let's move from the map to the metal, the receiver, the quest for the green light.
Ah, yes.
Huh.
RTK initialization, the #1 cause of high blood pressure in the field.
I believe it. You're sitting there, everything's on, but the status bar is just glowing red. Standalone, float, and nothing works.
Right, and your first instinct is to blame the rover, the receiver on the tractor. You get out, you check the cables.
But it's not the rover.
9 times out of 10, it's the base station,
Sure.
the tripod just sitting over there at the edge of the field.
What's it doing? Or not doing?
Well, it has to know its own position perfectly, down to the centimeter, before it can send any corrections to you. To do that, it has to average its position by listening to satellites.
Okay, and the default is what, a 30-second average?
It is, but here's the catch. It's not just a 30-second timer. It has to get 30 seconds of good data. The system is looking for a tiny RMS error less than 0.1 IMPU in good satellite geometry, a PDOP under 3.
So if you set it up next to, say, a big oak tree,
Or green bin. The signals bounce around. The RMS value might hover at 0.15. It never hits the 0.1 target, so the 30-second clock just keeps resetting forever.
and the person in the cab is losing their mind.
Right. So the fix is either to move the base to a clear spot or you lower your standards.
You tell the software to be less picky.
Exactly. You go into survey options and you relax those RMS thresholds, maybe bump it up to 0.2. It's better to get to work with slightly less accuracy than to sit still waiting for perfection.
That's a great life lesson right there.
Just don't go too crazy with it.
Got it. Okay, another hardware issue. Short pole mistake. This sounds scary because the light will turn green.
Oh, this one is bad. It lets you work, but all your data is garbage.
It's about the antenna height, right?
Yeah. The software needs to know the height from the ground to the ARP, the antenna reference point.
And where's that exactly?
It's almost always the very bottom of the receiver where it screws onto the pole. But people measure to the middle or they'll rest the tape measure on the top of the dome.
So they're adding, what, 6 inches to the measurement?
Easily. So you tell the software the antenna is 6 inches higher than it really is. That means the software thinks the ground is 6 inches lower than it really is.
So every single cut and fill number for the entire project is wrong.
By half a foot?
Mm.
You're grading a phantom field. You cut where you shouldn't, fill where you don't need to. It's a disaster.
Wow. Okay, so always measure to the bottom.
Always.
And what if the receiver just won't turn on at all? The manual mentioned a zero power mode.
Ah, yeah. Sometimes it just plays dead. The trick is to press the reset key for exactly 1 second. Not a long press, just a quick one. It usually wakes it right up.
A 1-second press.
Yeah.
Good to know. Okay, so we're set up. GPS is green. Grid is right. Now we get to the design, the whole reason we have the software. Variable slope.
This is the magic. The old way was a planar design, like a tilted sheet of plywood. Super rigid.
Which means moving a ton of dirt to make a lumpy field flat.
A ton of dirt. A river of diesel. Variable slope lets the design roll with the land's natural contour. It saves a huge amount of earth moving.
But it's way more complex for the computer. And that's when you see that dreaded message. Infeasible solution.
The 3 worst words in the business.
It sounds like the computer's judging you, like your request is illogical.
That's exactly what it's saying. You've given it a set of rules, a box that the terrain just can't fit into. You said the slope must be between 0.1 and 0.5%, and the cut-fill ratio must be exactly 1.2.
And the software says, nope, can't do it.
Right. The math just doesn't work. So to fix it, you can't change the field. You have to.
Change the box, make it bigger.
Exactly. The easiest thing to do is widen the constraints. Instead of locking the cut-fill ratio at 1.2, give it a range, say 1.1 to 1.3. Give the math some breathing room.
And if that's not enough...
Then you look at the monotonic setting. This is a huge trap.
Monotonic. Sounds complicated.
It just means always going down. You're telling the software that the slope can never, ever flatten out or go slightly uphill, even for a foot. It has to be constantly draining.
Which sounds like what you want.
It sounds great and it looks beautiful on a graph, but it forces the machine to move a colossal amount of dirt. It has to slice the top off every little rise and completely fill every little dip.
You can't just ride the waves a little bit.
No, and it dramatically increases your earthworks. So if you get an infeasible error, one of the first things to try is unchecking Make Slopes Monotonic. It often solves the problem and saves you a fortune in diesel.
Uncheck the box, save the money. I like it. Now, what about real-world obstacles? There was this gas line scenario in the manual that was fascinating.
Ah, the unmovable object, yes.
So you've got a pipeline running 3 feet under the surface, right through your field. You cannot, under any circumstances, cut dirt there.
But the software doesn't know that. It just sees a hump and says, let's shave 3 feet off this.
Exactly. So how do you tell the all-powerful algorithm, do not touch this spot?
You use something called node constraints. You actually identify the specific grid points, the row and column numbers that sit right on top of that pipe.
You're putting a digital thing around it.
Precisely. You make a little text file with those node numbers and you give it one rule, max cut, 0, 0. You load that into your design.
And it designs around it.
It gets creative. It designs the entire field around that constraint. It will build up the areas next to it, route the water a different way, whatever it takes. But it will not touch that spot.
It respects the force field.
It does. And knowing how to do that is what really separates the pros. It lets you account for reality.
That's awesome. Okay, last segment. Cleaning up the data. Sometimes you do everything right, but the map just looks messy.
Visual noise. You see this a lot with drone or LiDAR data. They're almost too accurate. They pick up every tire rut, every clod of dirt.
So the contour lines look like a lightning storm. You can't see the big picture.
Exactly. The fix is easy. It's the F4 key, regenerate contours. You just increase the interval. If it's showing you lines every 1/10 of a foot, change it to every 1/2 foot. It smooths out all that noise.
Simple enough. But there's another glitch, the jumped corner.
The triangulation glitch, yeah.
It looked like the software was taking a shortcut.
It is. The software connects all your survey points with triangles to build the surface. But if you have a sharp inside curve on your field, like a kidney bean shape, sometimes it gets lazy.
Okay.
Instead of following the curve, it will draw a triangle from one side of the curve straight across the gap to the other side.
And create a patch of fake land in the middle.
Ghost dirt. And the software includes that ghost dirt in its volume calculations, so your cut and fill numbers will be completely off.
How do you kill the ghost?
With a digital scalpel. It's a polygon selection tool. The shortcut is Credle plus Shift plus click.
Critical plus shift plus click.
You just draw a box around those bad triangles, hit delete, and poof, they're gone. The boundary snaps back to where it should be.
That is a very useful command to remember.
It can save you from chasing your tail wondering why your dirt volumes don't add up.
So, if we bring this all together, a quick workflow for someone heading out to the field tomorrow, what's the summary?
First, get the grid right. Use lat long for your import and stick to that 25-foot spacing.
Then check your hardware.
If that light is red, check your surroundings. If you're near trees, relax the RMS settings. And for the love of all that is holy, measure your antenna height to the bottom of the receiver.
And when you hit that infeasible wall in the design,
Widen the box. Give your cut-fill ratio a range and uncheck monotonic. Let the design breathe. And use node constraints for real-world obstacles.
it really shows that this software, it's not magic. It's just a really, really powerful calculator.
That's it. The best fit button is a starting point. It gets you most of the way. But it doesn't know about the gas line under the ground or the mud you're driving through.
That last 20% is the human touch.
It's the operator knowing how to feed reality into the calculator so it gives you a useful answer. That's the real skill.
Well put. And that's our deep dive on AG Form 3D. Hopefully, the next time you see that error message, you'll know exactly what to do. Thanks for listening.
Safe grading out there.